Hi, my name is Ashish Kumar, and today I'll be talking about transforming your network to control, observe, and securing your APIs. So, a little bit about myself before we start. Um, I've been in the tech industry for about 20 years now. I started my career as a software engineer, then moved into API product management, and was successfully able to create an API product based revenue stream at the telco that I was working. Um, that business is more than about $100 million in revenue at this point of time. Uh, After that, and before what I do right now, I spent about 5 years as a customer engineer at Google. And very recently, I've just been sort of accepted into the CNCF, that is Cloud Native Computing Foundation Sydney chapter as an organizer. So I'll be bringing in more content from the CNCF landscape. What I do right now is work for a company called Solo.io, essentially the leading company across the globe that works on solutions like Service Mesh, API Platform, and related cloud native technologies. We are a fairly well-funded organization. We have quite a large number of customers, including some of the largest banks and telcos around the world. And we contribute quite a lot to these open source projects, um, shown on the bottom left, like Istio, Envoy, Kubernetes, Cilium, GraphQL, and UPF. Uh, if you have any questions on any of these technologies, do reach out. Find us on the booth, or just find one of us. Okay, let me talk about sort of an agenda of what we're going to talk about. And this is sort of an attempt to bring onto a paper, on a slide, some of the thoughts that I have. And majority of these thoughts come from the knowledge of speaking to a very, very large, number of um, technical engineers, solution consultants, product owners across a large number of organizations, primarily in APAC, but also globally, who deal with some of these problems on a day-to-day basis. And the problem space that I'm talking about, like I said earlier, is connecting applications and how those applications become part of network as something that we're going to see here. So let's start with the first and the foremost. And this is sort of an assumption that I've taken for this conversation, that majority of the audience here know what an API gateway is, but also know how to use an API gateway, how to deploy an API gateway, what are all different API gateway vendors there are, what all different open source products there are. What are some of the related technologies that are required to actually productionize and operationalize an API gateway? There's a lot of information. I'm going to try and contain to some of the information that I can put on the slide. And in a typical reference architecture, we will see an API gateway as sort of a front end or an edge node that accepts all incoming traffic and also accepts traffic from internal sources or applications, and then provides policy control or some level of access control, along with some of the capabilities like transformation, routing, so on and so forth, for services. Now, the services landscape is kind of a fairly distributed today. Now, you have some services running in the cloud, again, in different sort of postures, serverless, virtual machines, or containers. At the same time, you will have some services running in your own data centers, typically on virtual machines, but we've started to see a lot more containerization in that space. And also, what we've seen in some recent years is proliferation of some SaaS-based services, including your identity platforms, your logging, metrics, CRM platforms, marketing, data analytics. Quite a number of those services are much better utilized or consumed in a SaaS format. And last but not the least, there is a data and a queuing layer that's usually combined of one or more large databases, or one or more queuing platforms or message buses, so on and so forth. Uh, Now, this to start with, on day one, this architecture worked really well. It was able to create a lot of early successes for a large number of organizations who were looking to modernize themselves, using digital technologies. And that sort of happened almost about 10 years ago. Things have sort of shifted a slight, more than a little bit. Right? So the other thing that we don't always get to see when we talk about these reference architectures are these some legacy underlying sort of nodes or assets that are also required to make this communication happen. And one of the foremost and the most important one in that space is your firewalls. Now, it's when you're deploying new services, it's not only a matter of just exposing an API. You have to have the right firewall burns done. It's still a thing, and it still is a time-consuming activity in a lot of organizations. So while we are seeing that a SaaS-based posture for an API gateway or any sort of service that requires any level of compute, um, there is these additional things that we sometimes overlook that become quite important for day-to operations or productionizing those systems. In addition to that, let's look at a typical scenario how a packet sort of moves between these services when internal applications are trying to talk to each other. So a service running on cloud, if needs to access a service running in a data center somewhere, will talk to the API gateway, and which API gateway will talk to one or more identity providers or policy engines to perform an identity check. And then after having done that, we'll forward that or proxy that message to the serving entity. This is what we typically call as a hairpin architecture. It looks somewhat okay in this context, but it starts to look really sort of awkward when those services are sitting next to each other, um, wherein the platform kind of is reliant on an external entity just to find out if service A can talk to service B or not, while sitting next to each other. This problem gets a little bit more complicated, painful, and expensive when those serving entities are your data layers, databases. Then that posture becomes a little bit more difficult to manage. So we started to see where we got the initial success with this API gateway pattern. It's sort of filled with quite a large number of both small and kind of big size problems. So um, one of the first things that a developer does, like, and looking at the same view from a developer's point of view, developers will actually implement some business logic in the application that they're building, the code that they're writing, and that itself is a non-trivial process or activity because of all the additional overhead of communicating with the API gateway, and we'll see some of that in this conversation later on. Now, once that's done, they'll implement some admin-related stuff. Then they will check in and deploy the app. Now, some of this may be automated. Then they will go ahead and start building an API proxy, which gets deployed on the API gateway because it's sitting somewhere else. Even if it's not a SaaS service, it's sitting somewhere else. So it needs to have its own assets or modules and individual components that needs to be built and deployed. And once that's done, then as a developer, you also try and figure out, and sometimes quite painfully, hey, how do I connect these two applications? I've just created a new application, deployed a new application. It sort of has its own set of IPs. Or this is a vendor product, gets deployed a new set of virtual machines or even containers, but this is new infrastructure. How do I hook it up to all of my existing assets? Thankfully, we don't really have to do point-to-point connections, but even with an API gateway, that's still a requirement. And At least in my experience, those firewall burns end up taking at least about 3 months. Now, once that's done, then you'll perform connectivity tests, assuming that some of the application level system tests have been kind of done by a CI/CD pipeline. And once all of that's done, then the application sort of is rolled out along with its API proxy into production. And it takes a lot of time for this process to actually happen. From implementing logic and code to rolling out the applications ends up taking quite a bit of time, even with agile methodologies in place. So now, some of these problems then we try to address and successfully were able to address with the micro gateway API pattern, wherein what we've done now is we've taken what capability an API gateway provides, and we've taken smaller pieces of that and started to deploy them closer to where our services are. Now it requires less number of network connections, it requires less number of firewall burns, and obviously, because it's a micro gateway, it typically comes with a reduced feature set, which works perfectly fine for these use cases. But looking back at the developer's deployment flow for this setup, that doesn't really change very much. We've taken away the pain of firewall burns for majority of the cases, but we still have to deal with the application developer having to figure out how to connect to the gateway, how to secure, authenticate itself to the gateway, how to implement observability, and how to implement all of the admin related stuff like service discovery, load balancing, if client-side load balancing is required, so on and so forth. So the next thing that sort of came from this overall idea of trying to reduce this admin overhead was service mesh. So it actually was a bottom-up sort of technology that came into existence by some of the work done by folks at Netflix and Lyft. And what happens in a service mesh? So let's have a look at that. The textbook definition of what a service mesh is, it's a programmable framework that allows you to do all of those admin things without having to build them again and again. The other way to look at it, it's sort of a dedicated infrastructure that's available to your applications. The applications don't really know that service mesh is in some shape or the other. It just can, from that point onward, starts expecting some of the capabilities that the infrastructure will provide. And that would look like, hey, I'm connecting from service A to service B, then I will assume that the communication is secure, it's encrypted. I will assume that the relevant observability is available by the infrastructure itself. I will assume if any load balancing or traffic management is required, if there are multiple versions of service B running, it will automatically happen. And I don't have to really worry about that. And that's essentially what this dedicated infrastructure starts to provide. So now let's look at it in the context of where we were with our API gateways to what it starts to look like. And as you can possibly see that from this diagram, you're probably not going to be doing those hairpins quite a lot. The services are able to communicate with each other using the mesh, and we'll see how that happens. But at the same time, all incoming and all outgoing traffic is controlled. So that improves your security posture significantly and reduces both the number of firewalls that you need as well as the firewall burns required. Now let's look at what really happens and how this service mesh enables this capability. So you have an application running in some sort of a posture, either on a container platform or a virtual machine. What you're going to do is, like I said, today, this application also has to take care of all of these things in one way or the other. Figure out, every application developer has to figure out how to do all of this. So what happened at these both Netflix and Lyft? The engineers, they took all of these pieces of code. Initially started with writing a separate library for that. But those separate libraries, then depending on the programming language in use, you would need something for every different programming language. Again, if there are multiple applications using the library, then upgrading all the applications when library required a fix was also a big issue. So there's a there's a mindset shift there, is that how about we decouple these capabilities altogether and remove this from an application and add it to a separate application which can work as a sidecar for my application that runs the business logic, and move that sidecar closer to the infrastructure that's available to the application. With that, one of the earliest projects in the service mesh sort of happened on the project called non-wire proxy. And this forms the basis of quite a large number of technologies that we use. It also forms the basis of quite a large number of layer 7 load balancers that a number of cloud service providers use. Now, there's a single application running a sidecar. You start with that, and eventually you would then have that mode of operation made available to all of the applications that are running in your infrastructure, whether they are running as containers or on virtual machines. And this can sort of work in parallel with any API gateways that you have or micro gateways that you have. That posture does not really change. What changes is that the connectivity from the application to the API gateway is now a sidecar responsibility rather than an application responsibility. Continuing this format, what we also started to see is that the network that's available to a lot of applications today is virtualized. What that means is a software-defined network. So if it's software, we could kind of figure out, hey, some of these capabilities that you're running in this separate application can be made part of the network itself, right? Especially when it's something as simple as, can application A talk to application B? And all of it's done using advanced application identities or service accounts or workload identities or asset registers. So with that effort, we started seeing a software-defined network capability. In Istio world, it's called ambient mesh, where in the first version of ambient, move that sidecar capability into the network. And with that, we finally achieved network as an API. So you've transformed what you used to do with APIs. So you've actually transformed your network to achieve what you used to do with these API gateways to provide connectivity, security, and observability for your applications. And as time passed, there were new technologies that were introduced, ambient mesh, which changes from Envoy to Rust-based proxy, and another capability called Cilium, which provides a container network interface and allows containerized applications to have that access to that capability out of the network itself. Right. So with this, we also figured out, hey, we are running these capabilities. There's no real dependency on how how the underlying physical sort of infrastructure works. So, and we also were able to establish a well-defined pattern of connecting across different networks. So these services can be spread across multiple cloud providers. You can have some applications running on AWS, some other applications running on Azure, as a combined entity providing the set of capabilities that your organization need to. Moving forward, what we also saw, once we have this mesh available, we can remove some of the applications fairly easily. and then replace them with their sort of newer versions without really impacting any of the other applications quite a lot. And these applications only contain business logic, so it's a small feature set that's getting replaced. There are quite a number of strategies available for it, like blue, green, A, B, canary, multiple versions, so on and so forth. But yeah, service mesh makes that just very, very easy and accessible. You can also swap applications across different cloud providers, depending on, some applications might want to use some specific kind of database that some specific CSP provides. You can actually move them closer uh, without really impacting anything else in your setup. Now, looking at it from an application point of view, again, that all of these services that as a developer, I had to build in my applications, or at least worry about in my application at one point of time, I can just assume that this is available from the underlying infrastructure. What that does to my deployment flow for new applications is I've gone from having a large number of steps that may require a large amount of time to just this, which is implement logic, checking the code. Most of the times you would have a CI/CD pipeline promoting the code to high-level environments and rolling it out into the production. But as a developer, I don't have to do anything. If all I need to do is that, hey, I've written an application and I want that application to be exposed externally through the gateway. I may choose not to if an application consumed by internal services only. I may also choose to specify what kind of an authentication this application requires for it to provide the services that it needs. And this is all what I need to do for that, because this tells my underlying infrastructure to perform an authentication step before you provide access to this service. Looking at it again from a mesh point of view, what we now start to see is sort of this is becoming a grid or a fabric where you can deploy, a large number of services, and those services might be the applications that you're building. Those services might be some COTS products or vendor products that you've bought. Those might be some one or more identity services, both for your applications and for your workloads, and leave some space, not in terms of resources, but leave a well-defined mechanism for introducing new applications into the mix whenever required, and have a consistent way of exposing those services to the outside world, and ensuring that all of my grids in my mesh are fully secure, encrypted, have the right observability, and have the right level of connectivity that my applications need. And with that, I'll stop this conversation and talk. Thank you for your time.